Hello, and welcome to our Senior Design 1 mini demo for Group 18. First, let's go over some of the major hardware components that we've purchased. For the locking system, we will be using an ESP32 attached to a NEMA 8 motor for the locking mechanism. To power this motor, we will be using a TMC2208. Also, we will be using a PN532 for NFC communication. The MKR MB1500 will be our tracking system MCU, and it will have a SAM M8Q GPS module connected to it. It will also have an HM10 Bluetooth Low Energy module, as well as a 5-volt buzzer for the alarm system. To power both of these systems, we will be using a 10,050 mAh battery, and to charge, we will be using a TP4056. We have also ordered the PCBs that we will be using. In total, we will have 5 PCBs. 1 for locking, 1 for tracking, 2 for voltage regulation, and 1 for motor control. Now we will show you the progress that we've made so far during SD1. First is the locking mechanism. As you can see, when we put a command into the serial monitor, the lock opens up, and if we put another command into the serial monitor, it will close. After connecting the oscilloscope to the M1A pin on the motor controller, we can see the pulse width modulation or PWM signal telling the motor which way to turn. Next, we will be showing you the alarm that will be on our tracking system. Please make sure to turn down your speakers, as this alarm is very loud. Next, we will show you our Bluetooth connection. The ESP32 acts as a server, with the HM10 being the client. Right now, the ESP is broadcasting a message, but the HM10 is not receiving it. However, we can send an AT command to see what MAC addresses are in the area for the HM10 to connect to. We can then send another AT command to connect to this MAC address and receive the messages that are being broadcasted by the ESP32. Next is our GPS module, which in this example displays the longitude and latitude coordinates of the device. As we can see, this is accurate with the coordinates that are displayed on Apple Maps. Last, we will demonstrate our LTE communication. The Sera R410M module, which comes with the MKR 1500, can connect to either Cat M1 or MB-IoT networks. For this project, we have chosen to use LTE-M and have purchased a SIM card from our provider, Hologram. When we run the Scan Networks example code from Arduino, we can see that the board is able to recognize various carriers in our area, such as Verizon, AT&T, and T-Mobile. We can see here that the board is receiving the maximum amount of power from the cell tower, which is minus 51 dBm. We can also see that our SIM provider recognizes and can connect to the board. Thank you for watching, and we look forward to continuing this project in Senior Design 2.